So basic counting principle says this. Suppose one event can be chosen in P different ways and another independent event can be chosen in Q different ways, and the two events can be chosen successively in P times Q ways. And so what does that mean? Well, let's look at number one. And I'm going to be doing some of these problems with you. This is your homework, and I'm kind of doing part of your homework with you, so you do want to make sure you're doing what I'm doing and have the work shown there. And then whatever I don't do will be your real homework, okay? But number one says a band sells t-shirts in 3 sizes in 2 different colors. And so let's say we have size 1, 2, and 3. And 2 colors, I'll say blue and green. Okay. How many different t-shirts are there to choose from? This is the basic counting principle would say, well, you have 3 sizes, so that's 3 times you have 2 colors, 2, and you get 6 as an answer. But every problem we do, you've got to ask why. It needs to make sense to you, okay? I do not want you relying on formulas. You will do awful if you rely on formulas. Trust me. You rely on your understanding and making sure your understanding is growing, you'll do a lot better in this unit. So why 6? Right now, the best, well, does anybody have a good reason why? It's not, this one's not a hard one to explain, so you did have one, yeah. There you go. So you got each size, 1, 2, and 3 can be paired with either blue or green, right? So you can have 1B, 1G, I'll list them out. I could size 1 with blue, size 1 with green, or size 2 with blue, size 2 with green, or size 3 with blue, and size 3 with green, right? And there we have it. Often people use tree diagrams to help you see this. So like you have your paths. So here you start, you can take, you pick what size you want, and then after you pick what size you want, you pick what color you want. And you look at, well, at the bottom I have 6 different destinations, right? And so there's going to be 6 different ways. We can list them, but that's fine. And it's easy on a small scale to see this, but when numbers get really big, you're not going to want to list them out. You're not going to want to create a tree diagram, and you're going to want to understand a method that's useful, and that's this fundamental counting principle, and why that would be the case. So let's amp it up a little bit, and let's look at number 4. So how many different 6-character license plates can be made if the first 3 characters are letters and the next 3 are characters or digits? Letters and numbers may, in this case, repeat. So how many letters are in our alphabet? We've got 26 letters, A through Z. How many digits are in our numerical system? Now, a digit is a symbol that makes a number. So like 23 is made of a digit 2 and a digit 3. Okay? Or you can think a digit is what you would use, would be on your telephone. Right? How many digits do we have? 10. And we work in a base 10 number system. That's why we have 10 digits, right? If we worked in a different, like a base 2 number system, you'd have only 2 digits you're working with, and so on. So there's only 10 digits, 0 to 9. Okay? So 10 digits. So let me make this one strategy that you want to help you with understanding, because things are going to get, some of these things will get really complicated, is to work at a smaller scale. Okay? To scale it down and just try to get some understanding there and then go back to your problem. And so here, I'm just going to scale this down a little bit And let's say we had a 2-character license plate, okay? And they're just letters, simplifying it. Only letters. I want to pick 2 letters. I can repeat them. How many different 2-character license plates could I make with letters? How many? 18? Well, okay. More than that. So yeah, by the way, you're probably going to want a calculator handy. If you brought your calculator with you, this is definitely a calculating unit because we're going to deal with numbers that are really big. If you didn't bring your calculator with you, no worries, but bring it with you tomorrow or Friday, next time you're here. But look at this. If I just have 2 letters, I can have AA, AB, all the way down to AZ. How many are there? 26, so you know it's more than 18. Then I could also do BA, BB, all the way down to BZ. So there's another 26. Then I could do CA, see what I'm doing here? CB, that's a B, all the way down to CZ. So I have 26 going down, and I'm going to have 26 going across. So 26 times 26 is how many I'm going to have, which is a big number, right? That's just what 2. Now we got 6 digits here, right? For 6 characters that we want. But again, fundamental counting principle says, hey, if there's only 2, you multiply your possibilities together. And that simplifies the problem, okay? So we actually have 3 letters and followed by 3 digits. So how many choices do I have for that fourth character? How many digits are there? 10. And then I pick another digit, and then I pick another digit. And then we multiply all that together, and it's a big number. What is it? So there's 17,576,000 different license plates that could be made with that criteria. Okay, quite a bit. So we're counting some big numbers in easier ways here. I want you to try number 6. That's the next one we're going to do together, but I want you to try it ahead of me. Lots of you have been frequenting the movie theater, watching the new Endgame movie, right? And I have not seen it yet either, but in how many different orders can 6 people sit in a row of 6 seats at the movie theater? And use the fundamental counting principle to help you. And if you're not sure, scale it down. Try 3 people. Anybody have an idea how to approach this problem? Got 6 seats. Here they are. No ideas? Yeah? Okay. Can you tell me why? Why'd you pick 6 in the beginning? Okay. There's 6 people, and we're like, well, who's going to take that first seat? There's 6 options, right? So somebody sits down. So 6 options for that first seat. One person picks it. Now there's 5 people left. So how many choices are for that second seat? 5. Now 2 people are sitting down. There's 4 people left. So you got 4 people to choose for that third seat, and so on. And that comes out to be, what is it? 720. And again, you can check on the bottom, make sure the answer's there, right? If you were unsure about your method, scale it down to test your method. Like say, like I think it's this, but I'm not sure. Which you can do is, if I did 3, I could say, well, I can actually do something that you can list out. So if I had A, B, C, that could be A, CB, BAC, BCA, and CAB, CBA, and I got all my methods. So that's 6. So would that work? Let's see. Well, my method was 3 choices and 2 and 1, and I multiply that together to get 6. And so that, on a smaller scale where I can compare 2 methods, that gives me confidence that what I did on a bigger scale worked. I don't want to list out all 720, but I can list out 6. That's not bad, right? So 720 is what we want. On some of these, you'll see, like number 8, you'll see EC. That stands for extra credit. So that is optional for you to do. It also tells you it's a little more challenging problem. But if you do it and you get it right, then you get extra credit on the homework. Okay, it has to be not only done, but it has to be done correctly for the extra credit part. Also, there's a correction on the answer. The second 6, if you change that to a 12. And I think I've given you enough to get started on this. I'm going to pause there, give you just maybe 5 minutes to do a few more, and then we're going to start with section 2. Okay.